Matlab interface to the Lumascope. First we look at some of the functions. We're running a Basler camera right now. This is the function that initializes the Basler camera through this init routine, and then it allows for setting gain, exposure, and getting an image, and that's all it takes to get an image out of the Basler camera, calling this step function. This is using Matlab's image acquisition toolbox, so again that's handling a whole lot of the magic. Params is a way to request these video parameters out of this function, because the scope of vid, this video object, is limited to a persistent variable inside this function. So if you look in Matlab's workspace, it's clean. There's no global variables other than the simulation variable that I've been using historically, so I can run the same software and debug it without having a microscope present. I just set sim to true, and then this function would just exit right up here. So anyway, that's how we interface to the Basler camera. The way we control the LEDs is through LSLEDs. This guy also uses a persistent variable LS620 to keep a hold of the DLL, and then it calls LED control right. Let's fire up the GUI, lsgui. Start streaming. There's not much to see. It's pretty dark. Let's go to bright field, turn up the brightness a little bit, and silly color map, let's go to grayscale. We are running pretty darn slow. Not sure why that is. Let's turn down the gain. 16 to 18 frames a second is somewhat respectable. H&E slide. If we play with the brightness, you can see some decent responsiveness. The Matlab's figure windows support things like zoom, so we can do zooms, and I now have the side graphs working. And so that helps focusing. And if we switch to green here, brightness helps turning up. So we're still zoomed way in. Restore view, there's a whole slide. Bright region in there. We see it in both places. Again, if we move that over, move it up and down, you see how the curves follow. Alright, so one thing I like to do is take green, map it to green, but let's map bright field to red, none to blue, and then we can stop streaming and switch to a sort of live RGB. And here we're running at about 3 frames a second, not nearly as fast, but it's sort of cool again to be able to zoom in, play with the focus a bit. And this is running at 3 frames a second. Here's what it looks like from the top. I've replaced the sample with an out-of-focus business card for the purpose of looking at optical alignment. And here, the first screen, or first image, you can see a little bit of the curvature that we expect, and clearly some off alignment. I've added a target which is easier to, or only shows up as we start streaming, and for that we need to have a little bit of LED. So let's see, the red LED isn't the world's brightest. As we can see, that's full brightness, so we may have to crank up the exposure a little bit. You can see exposure is slow to adjust, but that's doing it. Gain also, which is slow to make changes. Does gain affect anything? It does indeed. So we're seeing the camera does respond to both exposure and gain, albeit slowly. Now we can change the color map. I made this color map for Eric. Oh, and again, let's put the target on. A little easier to see in a jet color map, or if we replicate the jet, I called that Brian's. We can see here the alignment. And let's switch to green. Green is quite differently aligned. The other thing too that helps with alignment, these little dots represent the max and min, or the maxima of the peak and the mean, and so they're dancing around to coincide with the location. So for adjustment, it'd be pretty easy to just try and get those dots over. Let's see how blue does. I think blue is super bright. We've already saturated, I think, with blue. There we go. So blue is pretty well aligned. And if we switch back to green, we see the misalignment of green. And back to red. Red isn't so bad.